Assalamualaikum and salam sejahtera. Okay, now we already in chapter 2 for the topic of differentiation and application. So in this chapter, we will learn how to differentiate functions using several techniques of differentiation, and also we will look at how to differentiate the some of the specific function like implicit function and parametric equation, and the function involving parametric equation, and the application of differentiation in real life problem. Okay, before we look at the techniques of differentiations. So we have to know what is the differentiation first. The derivative is a fundamental idea in calculus. Okay, the process of finding the derivative of functions is called differentiation. So this is the main definition of the differentiation. By implementing the concept of limits, the derivative of fx is given by this formula. Okay, the domain of f prime consists of all x in the domain of domain of f for which the limit exists. The definition of the derivative is derived from the formula for the slope of the line. Okay, geometrically given by this graph, the derivative is the slope of the tangent line to the curve at a point of interest. This point of interest. This is the curve y equal fx. Then let's say the point of interest here is x. So the tangent line is given by the red line. Yeah? It is sometimes referred to as the instantaneous rate of change. But since the tangent line only has one point at the interval, at the not the, at the interval, at the curve, therefore we approximate the slope using the secant line. Secant line is given by the black line here. Okay, this by this concept, okay, comes the first principle limit of first principle, where this is the definition of the derivative. Unfortunately, computing the derivative using the definition can be quite difficult. Okay, fortunately, the rules for computing the derivative for different types of functions are well defined. These rules enables us to calculate derivatives more efficiently. Some basic rules or properties of formulas. Okay, let A be any real numbers. So if we have the two functions, uh, uh, add we add or subtract two functions. So to find the differentiation, this is equal to differentiation of each functions. Then add or subtract. Okay. If we have the function multiply with the scalar a, okay, so we just can multiply scalar with the differentiation of the function. This is the basic properties of the differentiation. However, this is not simply rule for the product, okay, for the multiplication of two functions or division of two functions, or the quotient. The other basic differentiation is given by this table. So you can look at the each of the function. This is the basic function. If we have a is constant, so the differentiation of constant is 0. If we have the x power of n, this is a power rule. Okay, this n not necessarily integer number, and can be rational number. Okay, can be any real number. Okay, so this is the power rule given by this formula. So we also have the differentiation of the trigonometric functions. Sine x becomes the differentiation of sine x is cos x. The differentiation is for cos x is negative sine x. Tangent, okay, and so on until cosecant x. Okay, here I also put the function, the main formula for the cotangent, secant, and cosecant. Okay, and we also have the logarithmic function, ln and also log base a here. So this is the differentiation, and the exponential function for the exponent x, and also a power of x. This is also the exponential function. Okay. So we will not discuss the example for this kind of functions because this is just the basic function. You should know how the differentiation. Okay, we will directly go to the several techniques of differentiation. Okay, for the previous section give some basic rules or properties of formulas for finding the differentiation of a function. However, we must be careful when differentiating product, quotient, or composite function. For these types of functions, more advanced rules need to be applied. Okay. We will discuss three rules. Okay. The first rule is product rule. The second rule is quotient rule. The next one is the chain rule. This is more advanced but very important rules in for differentiation. Okay, it can occur in every functions. Okay, for in this video, okay, we will discuss the first rule, which is the product rule first. For the product rule used to differentiate the product of two functions. Okay, we have y function is given by product of two function, hasil darab dua fungsi, ux vx, then dy over dx is given by this formula, u prime v plus u v prime, or any formula that you already learned before. Okay, you can use your own formula that you have memorized. Okay, so we will look at the example. So for the techniques of differentiation, okay, the product rule, determine the derivative of the following function. If you look at the function, okay, for the product rule, this is you don't need to expand this function. Okay, we will use concept of product rule to find the differentiation of this function. Okay. So for the example here, okay, for f prime x, you can use the df over dx, okay, or you also can use the f prime x. Okay, because we have here the product function, the multiplication of two functions. Okay, So we can use the product rule. So the product rule is given by u prime v. U prime is du over dx, but we just use u prime, u prime v plus u v prime. Okay, so what is u, what is v? So we define this as u and this one is v. Okay, so u is 2x plus 1. Okay, v is 3x squared plus 2. So u prime is du over dx. Okay, for the first time, I will write u prime is du over dx. For the next example, I will just assume that you already know that u prime is du over dx. So v prime is dv over dx. So differentiate with respect to x. So this is 2. This one is 6x. Okay. After we obtain the u prime and v prime, okay, then we can just substitute into the product rule formula. So u prime is 2, v is 3x squared plus 2 plus u. So u, what is u? U 2x plus 1 times want to move this. Okay. Okay, so u v prime is 6x. Okay, so you can leave here, but because this is just a simple function, you can simplify this function. So 6x squared plus 4 plus 12x squared plus 6x. Okay, when we when we combine the same term, so we have 18x squared plus 6x plus 4. Okay. 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 That is the basic of the product, the basic function. This function, the function in example A is just the polynomial function. Okay, you can try for example B. So I will give the answer. Okay, for the example B, you can try this by your own. You have to try. So we have u prime v here is 15 r squared. Okay, plus 3. Okay, r squared plus 3 plus u 5r cubed plus 3r plus 1 times 2r. Okay, this is the answer. You can leave here, or you can simplify this one. So you try to simplify by your own. Okay, now we move to the example C. Okay, for the example C, involve the square root. Okay, so be careful about the differentiation of the square root. Okay, so this one is u, this one is v, or same as this one is u, this one is also v. Yeah? Okay, for the square root, so the f prime. Okay, so the f prime x is equal to u prime v plus u v prime. Okay, but now, okay, we need to find the u prime and v prime before we substitute into the formula. So u is square root x plus x. V square root x minus 1. Okay, you need to know that square root. If you already know, so you can directly differentiate. However, if you are confused with the power, so we rewrite this as x to the power of 1 over 2 plus x and v prime. V also x power 1 over 2. So we don't need the bracket here. Okay, minus 1. Okay, so u prime. Okay, so we need to differentiate x power of 1 over 2. Use the power rule. So 1 over 2 x, 1 over 2 minus 1 is negative 1 over 2 plus x. Okay, the same technique, same differentiation with the v prime. So v prime is 1 over 2 x power negative 1 over 2. Okay, since 1 is the constant, so the differentiation of constant is 0. Then we substitute into the formula. Substitute into the formula. Okay, u prime. U prime is 1 over 2 x power negative 1 over 2 times plus x. Okay, times with v is this one, square root x minus 1. Okay, once again I need to move this. Okay, okay. So plus uv prime. So our u now is x power 1 over 2 plus x times v prime is 1 over 2 x power negative 1 over 2. Okay, you can leave the answer here, or okay, you can rewrite this as the 1 over 2 square root x plus x, okay, times square root x minus 1 plus this one I will use square root x plus x, okay, times 1 over 2 square root x. You also can leave in this form, or you can expand. Okay, you can expand this expression. 1 over 2 square root x times we get 1 over 2. I will try to expand this. 1 over 2 minus 1 over 2 square root x. Okay, plus x square root x minus x. I think this will become quite tedious. So never mind, I will try. So this one is plus 1 over 2, right? Okay, plus x divided by 2 square root x. Okay, then you combine which term. Combine 1 over 2 is 1 plus 1 over 2. This one will be 1 and so on. So you can also leave in the answer in this form. Okay, but my suggestion, you just leave your answer up to the first one or the second one. Okay, because I'm afraid that you make any mistake in expand the bracket. Okay, then the last example in this question is exponent. Okay, this is the exponential and the trigonometric function. Okay, even though this function is quite we look this as a quite simple function. However, we need to know that this is the product, okay, the multiplication of two functions, okay, which is the function of exponent and function of trigonometric function of uh, the different functions. Different functions. So let's say this is u, this is our v. So our f prime, once again, f prime x given by this formula. Okay, so our u now is exponent x, our v now is sine x. So u prime is exponent x. Okay, look at the basic of differentiation. So the differentiation of exponent x is exponent x, okay? But it depends on the power of the exponent. So the differentiation of sine x is cos x. Okay, then substitute into the formula. So our u prime is exponent x, v is sine x, plus u exponent x, v prime is cos x. Okay, you can leave here. Or you can factor out the exponent. So the answer is sine x plus cos x. Okay. Okay. As for the example 2, for the example 2 also the uh, what we call the product rule. However, we need to find the dy over dx at the particular point. Okay. So this point is x equal 5. So first we need to find the differentiation here. So look at this function. Okay, so for the tangent 3x, so this is the just the one function without any arithmetic operation. However, for the first function, you have your x times ln x. Okay, darab dekat sini ya. So multiplication of the function. Therefore, we need to apply the product rule. So this is what? This one is u. So this is v. As for the tangent, we can directly differentiate. So our dy over dx, okay, equal. Why I write the dy over dx? Because of the question. Depends on the question. Dy over dx is u prime v plus uv prime. Okay. So what is our u? Okay, u prime v plus uv prime. Okay, this one is for the term x and ln x. Okay, I put the first term here in the red bracket. So plus, okay, we can directly differentiate tangent 3x. So the differentiation of tangent x is secant squared x. Secant squared 3x, because now we differentiate the tangent 3x, so secant squared 3x. However, since we have 3 here, so we need to differentiate here. Differentiate 3x is times with the differentiation 3. Okay. Okay, alright. So now we need to settle the product rule. So we have u here. U is x, v is ln x. So u prime is 1, v prime is 1 over x. Okay, then substitute into the differentiation. So u prime, okay, u prime is 1, u prime is 1, v is ln x, plus u is x, v is 1 over x. Okay, gitu. Okay, plus 3 secant squared 3x. Okay, simplify. Simplify because this is just the simple function. So the first term is ln x, plus we can eliminate x. So this one is 1 plus 3 secant squared 3x. Okay, this one is not the final answer because We want the differentiation at x equal 5. Okay, so we need to substitute x as 5 ln 5 plus 1 plus 3 second squared 15. Okay, you can leave it here or you can just calculate this using your calculator and put the final answer. Okay, okay, thank you. Okay, I think okay, this is the final answer for the question 2. So this is the last example for the product rule. Okay, so I will end the video here. Thank you.